Okay, so for this example, we're going to build a small project. The project's going to be called Simple Calculator. And again, simple is a relative word, but we will definitely have a small calculator. So this calculator will have two features, where one, it will do basic arithmetic operations. Two, it can do trigonometry. Okay, so trig functions. So this means we need to identify the system's functional requirements and then later on dig in and look at the non-functional requirements. We get to make the difference between them. And then most importantly, we need to know who's this calculator for? Who's the audience? Okay, who's your client? Okay, who's going to interact with this calculator? Because that's going to dictate the type of interfaces, the level of depth that you're going to need for interfaces and features that match their skill sets, and or to make sure that we also provide a product that is useful. So that's very hard to do if you don't document your steps from the beginning. Because most of the errors that you're going to encounter while you're developing a piece of software will actually stem from the initial data acquisition or the initial gathering of the data that you're going to need to take the right decisions that will direct you into solutions that are acceptable for the end user and or your client or the stakeholders. So it's very important that you have some sort of documentation that can be verified, reviewed, and quantified. Now, there are several organizations out there that, have attempted to standardize the gathering of the requirements or the requirement gathering part. So that way you have the next phase will be to be able to do an analysis. Now, notice I mentioned the word phase. And sure enough, we're going to get into some sort of a life cycle development, or what we call a software life cycle development, okay? Where initially your first phase is trying to attempt to gather as much information as possible so you can analyze that information before you write your first line of code. So what are you going to do once you analyze it? Then you're going to model it and go back, depending on what kind of framework you're using for your software engineering project management. You might be going back and forth with your client. So let's say you're doing some sort of Scrum base under Agile. So if you're not familiar with that, don't panic. That's okay. We're going to get to that. We're going to have separate videos on project management. But the point is this. You're going to have what we call sprints. And at the end of each sprint, you may include your client in there or the stakeholder in your application to show them the version of the program or the product that you came up with, because the next time around, based on their feedback, you're going to reversion it to match their ever-changing requirements. So in an environment where, and this is challenging, where the requirements might change, this is where you're going to use things like Agile. You can, within it, there's a framework like Scrum or Kanban. There are a whole bunch of other framework you could use. I'm going to keep it simple. So it's going to be a combination of a couple things here. First, the modeling, okay, So that way you have a good idea where you're heading and figuring out the tasks that you're going to need so you can actually assign values for your tasks when you're ready to do some project management. First, understand the problem domain. So to do that, let me pull a piece of paper here that was written up by the IEEE. And it shows, this is really a template on how to do, let me just show you here, software requirement specification. So you need to start with this initially. So notice the breakdown. So I'm not going to go into all of the details, just to show you what's going to be needed. You need to state what the purpose of the system is. Okay. How are you going to document this thing? The scope basically is going to say how much work it's going to accomplish and not accomplish. So you set limits. Okay. And then you get into describing what this product is supposed to do, to figuring out what are the functional requirements for this device. What does it do? That's the functional requirements. While you're doing that, that gives you a chance to identify the entities that make up this product. And we will start with what we call a use case, where we combine the audience that interacts with this system with the various use cases they're going to be using throughout the system. Then you can get into, okay, what are the other non-functional requirements that will support your application? And that includes what kind of environment it's going to be, what limitations it might have, so on and so forth. So that comes in later. Okay, so notice here you got non-functional requirements right here. So performance is part of it. You know, how fast this thing is. Does it have to be responsive? What kind of security you're going to add to this, especially if your application goes over the internet. Do you need to encrypt? That sort of thing. But no matter what, you're going to end up with a calculator. That's the functional requirements. Okay? How you do it is a different game. What does it do is the functional requirement. Okay? So we need to be able to differentiate between functional and non-functional when we're doing what we call software requirement gathering. And then once we have an idea what we're doing or what we're facing, we could start modeling. So we're a long way from writing code, right? Prior to this, I have shown you how to build this calculator on the fly. And again, this calculator is going to be simple. I could also do it again on the fly, but that's not the point. The point is now we need to set up some sort of a system in place to develop some skills in terms of software engineering. So when you're handling larger projects, you're not overwhelmed. Okay? You have a system in place that will help you through this. So first, you need to do what we call so again, let me go to that document. Oops, gotta move my mouse here. There you go. Gotta keep my pen away from my mouse. So requirements, specifications. Again, you need to gather this. So for our case, we need to also identify what are the functional requirements and non-functional requirements for our calculator, and who the actor, who interacts with that. So I'm going to start with that audience. So who's the actor with this system? Okay, so typically a user. What kind of user? Now, if you want to get into the details of the user, you could do it right here initially. Could be an administrator, just a regular user, define what a regular user is, power user, engineer if they're going to use engineering or math functions, so on and so forth. Now, in object-oriented programming, you could have a hierarchy of users, which means you can have an actual object-type user with attributes. Or you could have user, which could be an abstract class, but you could have specific implementation of user if you have an engineer, you have a financial advisor, and so on, and they're going to use a different version of the calculator. So you need to take that into account. So remember now, I'm going to go back and say simple. So we're not doing OOP. So let me just do this. Object-oriented programming, we're not doing that. So I'm just going to keep it simple. It's regular user, right? So here he is, and we're going to draw a user right here. Okay, here they are. They need to interact with your system here. This is your system. This is your calculator. Okay, so what does the actor need to do? It needs to do some operations. So they need to interact with some operations. And we're going to find that we have two features. One of the features is we're going to have an arithmetic, basic arithmetic calculator feature, and two, a trig feature. Okay, so we know that we're going to need a case for the operation. And that's how the user interacts with the calculator. Now, what it will do, though, is that the operation will extend these cases for you. Aha! So let me just draw this a little bigger to see that that will create for us an extension. So what is that going to look like? Something like this. And this would be the arithmetic calculator. And this here will be another case, which will be the trig calculator. So here is what we call extend. Okay, good. So what else? Well, if you're going to do any of these, you need to be able, if you're going to do any of these operations, you need to be able to do input / output, right? Okay, well, the operation will include, let me just do it this way. And this here is include, right? This one here is also extend. In and out. Features. There you have it. I am keeping it again simple. This is what I want. So we're transitioning from the requirement elicitations that leads to a requirement list of things we need, where we have functional requirements listed, and then we're going to look at some of the non-functional requirements, and that allows us to transition to what we call a use case model before we actually write any code. Okay? And even then, we're not ready for code. For this simple calculator, I can, but that's not the point. We want to set up some steps on how we're going to do this. Okay. So that's great. So what non-functional? So these are going to be the functional requirements. What non-functional requirements might be needed here? I mean, other than the environment in which this calculator resides. The operating system maybe. Heck, the language you're using. It's going to be a Java. It's going to be C++. We're going to do this example in C++. You could do this in Java. It's very simple. Heck, you could do this in BASIC. Okay? All right. So what other non-functional? Maybe when you're doing trig, then the angles, as far as the input is concerned, has to be in degrees. Okay? So input, if you're doing trig, then the angle has to be in degrees. Okay. What else? If you're doing any arithmetic, all your variables are float type. Okay, right? So you can add 1.1 plus 1.3 or something of that nature. Any limitations? Well, that depends what you want when you're talking to your clients. You know, what other limitations or the scope of the project includes and doesn't include. Okay. I think we're good here. We have an idea what we want to do. We have two features, arithmetic and trig. So within that, when we're saying trig, what things in trig do we need? Maybe sine of an angle, cosine of an angle, right? Arithmetic, what do we need? We need plus, divide, minus, and multiply. What else? Maybe something to the power. Okay. Great. What else? Square root. Okay. So this will be the arithmetic functions. And we just need sine and cosine of an angle. Okay. So whatever that angle is, alpha will be in, angle alpha will be in degrees. Okay. And again, remember, don't write code until you have an idea what this whole project will entail. Okay, great. So now we start thinking about further. Remember, your code is right here. How do we go from there to code? There are steps to go through here. Okay. Now remember, I am not doing OOP. So if I was doing OOP, there will be specific steps that I'll have to take here. Okay. So, by the way, any of this representation that I'm going to be doing here is what falls under UML language. Okay? So, Unified Model Language. So, anything you do here, there are several versions of UML, by the way. So, you have to be, and it's getting more and more formalized. Whatever I'm doing here is very informal, but it gives you an idea. For example, if you were asked, what's the difference between extend and include, right? So you should be able to answer that question properly. Now, and what is a use case? All right, so you have an actor interacting with a system. This is a system, right? And then within the system, you have these use cases, right? Okay. And again, we're not doing OOP, so I don't need to worry about some sort of hierarchy of actors or anything of that nature here. Here's what I want to do before I get to the code. Maybe I'm going to group these, whatever these operations are going to be, I'm going to group them. I'm going to do what we call separation of concerns, which means, in a way, I know that these operations here are going to be really close to each other. So they can be grouped together. So is this one. All these operations. That's fine. But what's the relationship between arithmetic and trig? I'm going to what we call loosely couple it. So definitely I need two subsystems, right? One for trig and one for arithmetic. So if we were doing functions, I could have a collection of functions for all the arithmetic operations, and I can have a collection of functions for all the trigs. Remember, we're not doing OOP, we're doing procedural programming. So we're going to definitely need functions here, a collection of functions right here to do these operations. So this would be trig, this would be here the arithmetic. So we need to identify what these functions are going to look like. Do we need to design these functions from scratch? Right? Or do we need resources from somewhere else as well? So we need to maybe use resources like CMath, for example, right? Library, to do certain things like SQRT and POW, right? So that might be included here, okay? Same thing for the trig functions, right? So because the trig functions are going to have sine and cosine that are already predefined within CMath. So it's a matter of distributing some of these functions that are already pre-canned right into these two areas. Except here, our functions are going to be very specific to our application, where we're going to ask for data. So we're going to ask for input. We're going to output the results, and so on. Okay, so now that we have these two components, we need another one right here. And remember, we're doing procedural. We're going to do what we call a top-down design. So this will be the control function, right? And in your case, you know that is called main. And it will call the arithmetic. It will call the trig. All right? So we're going to give these conditions. What do we want? Do we want to do the arithmetic or the trig? Aha. So there is a condition associated with the fact that you're going to pick an arithmetic or a trig. The fact that you have a condition, these cases are extended. So that's another answer you might want to think about when you're asked about what's the difference between include and extend. For the include, no matter what you do, you're going to have an input and an output. Okay? All right, so that's the difference between extend and include here. So very important topic here to remember. So now we know, and again, I'm loosely doing this. I am not using really formal UML. So let's be clear. That is not formal UML, okay? But because I am doing procedural, UML are really good to use when you're doing OOP design, okay? In my case here, I am simply trying to identify what strategy I'm going to use, at least with these functions. Now, here's another trick. For my program, since this will be in main, now, if I can group these, then I can put these in their own .h header files. So if you were doing this in C++ or C, I can create a separate header file that will group all of these operations together. And that's what we're going to be doing when we're ready to implement this example. If you were doing this in Java, it's very simple as well. Okay, you can create or extend your own custom package that you will include in your project as well. Okay, so depending on what language you're using, you could have an extended header file other than the standard header file. And in my case, we're going to have one called arithmetic.h, and one is going to be called trig.h. In them, we're going to identify all the functions and define them. Same thing here. We're going to identify all the functions and define them. And then we're going to include these library files in the main program that we're going to need to run this program. Okay? So before you even get into this strategy talk here about all of this, make sure you understand the domain of your problem and what are the things you need. Once you have that, then this part is much easier to handle. So our next video will be about writing code for this example. So we're going to implement this idea into code.